Okay, we're going to go ahead and start working on the unit test. And let's begin. This one is radicals and exponents. So we have here which expression is equivalent to 4 to the power of negative 2 times 7 to the power of negative 2. Well, there's many ways of writing this, and I want you guys to be familiar with, all right? So one of the things I want you guys to familiarize yourself with is if you guys have a negative exponent. So for instance, 4 to the negative 2, okay? Remember that this is actually a fraction, which is 4 over 1. If you ever have an exponent that's a negative, well, we could always make the exponent positive by just flipping the numerator and the denominator. So this is the same thing as me writing as 1 over 4 to the power of 2. Okay? I could do the same thing over here for this one here as well. And I could change to 7 because it's being multiplied. 7 again is 7 to the power of negative 2. I know that my denominator for 7 is actually 1. I could flip these two over, and I could rewrite this as 1 over 7 to the power of 2. Okay? I could write it as 1 over 7 to the power of 2. Well, this right here, there's many ways of writing this out, okay? There's many ways of writing this out. Well, the first way is understanding these exponents over here, okay? With these exponents, I know it's multiply 4 to the power of negative 2 times 7 to the power of negative 2. Well, there's many ways of doing this. One of the first ways is actually seeing what occurs. I have 1 over 4 to the second power times 1 over 7 to the second power. Well, I know 4 to the second power really means 4 times 4. So this is actually 1 over 16. The next one is 1 over 7 to the second power, which is 7 times 7, which is actually going to be 49. All right. I could go ahead and multiply those two numbers in the denominator, and I could get 16 times 49 will give me 784. Well, if we take a look at this here, let's analyze A. Well, you learn in math that you actually work out whatever is in the parentheses, correct? So if we're going to work this out in the parentheses, this is actually 28 to the power of negative 4. Well, we learned this here that if your exponent is negative, we could actually switch it because this is actually 28 over 1. It's the same thing as me writing as 1 over 28 to the power of 4. Well, remember what the exponent means. The exponent means that this is 28 is being multiplied 4 times. So it is not by 4, but it's 28 times 28 times 28 times 28. So if we multiply 28 times 28 times 28 times 28, it gives you 614,656. 614,656. So according to this, A is not your answer. Well, on B, we don't really need to go ahead and move things around because it's already there. So on B is just 1 over 28 to the second power. Well, 28 times 28 will give me 1 over 784, which is the same thing as the one that we worked out. So one of our answers is going to be B. But notice it says choose two answers. Well, again, we have the numerator, which is 7 to the negative 2, and the denominator is 4 to the second power. Well, we can make the numerator positive by bringing it down. The denominator does not have to be switched because it's already a positive exponent. So I could rewrite this as 1 over 4 to the second power times 7 to the second power. Well, we know what 4 to the second power means. It means 4 times 4. So I could rewrite this as 1 over 16 times, well, 7 to the second power means 49, 7 times 7. And if you multiply those two together, 16 times 49 will also give you 784. So you have 1 over 784. So your next answer is also going to be C. So both of the answers here will actually be B and C. Okay, so let's take a look at the next one. Let's clear this out. So it says multiply and remove all perfect squares from the inside the square roots. Assume x is positive. Okay, so here we go. Well, this is important. This is a rule, guys. Well, kind of not a rule. It's just something you have to understand. If you're given this, guys, square root of 5 times square root of 3, you can write it as one single radical, which is square root of 15. With that understanding, we could write this as follows. All right. We take 3 times 5 is 15 times 10 will give me 150. All right, that's the first part. The second part, we multiply x to the 4th times x squared. Well, this is something that we have to discuss. This is actually going to be called the product rule. All right. When you multiplying, again, I'm going to write this down. This is called the product rule. All right. When you multiply variables and they have the same base, what I mean by the same base is that x and x are the same, then what you do with the exponents is just add them up. So this is what you really have over here, x 4 plus 2. So in this scenario, this would be x to the 6th power here. All right. So again, we have x to the 4 times x to the 2. It's actually going to be x to the 6th power. So now we wrote it as a single radical, okay, under the single root. And I want you guys to understand the index here, even though it's not written, is actually 2, unless it is given. If it is given, then it could be 3, it could be 4, it could be 5. But in this case, it's just 2. So now this is the part that we're going to break down the radical. Now, one of the things I want to find out is I want to find out two numbers that multiply together that gives me 150. So something that I should be looking for. Well, I should be looking for this. Square root of 0 is actually going to be 0. Why? 0 times 0, it's 0. Square root of 1 is going to be 1. Why? 1 times 1 will give you 1. Well, square root of 4 is going to be 2. Why? 2 times 2 will give you 4. And so forth. This is square root of 9 will be the next one. Square root of 9 is going to be 3. Why? 3 times 3. And then what should be the next one? Good job. 16. Why? Because it's 4 times 4. These are the common ones you guys should know by memory, all right? Why should you guys know this by memory? Because you know your multiplication. Square root of 25 is just 5. Why? 5 times 5. The next one you should know by memory is actually going to be 36. Again, 6 times 6. So the square root of 36 is 6. And we keep on going on and on and on. This is going to be 49. Good job. The next one will be 64. The next one will be, very good, 81. After 81 will be 100. And of course, square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. But you guys should also know the next ones. Square root of 121 is 11. The other one you guys should know, square root of 144 is 12. The next one you guys should know is square root of 169 is 13. Next one, if I'm right, is square root of 196, if I'm right. Let me confirm it. I'm pretty sure that's it. Yep. It's actually going to be 14. And up to, I think this will be a good one, square root of 225. Which would be 15. Okay? You guys can confirm that by yourself. But these are the main ones that you guys should memorize. Now, if we have a situation here, though, where the situation is this, is that we have square root of 150. If you notice this, square root of 150 is not a perfect square, okay? But that doesn't mean we cannot break it down. We know that I could go ahead and do this. Square root of 150, I could break this down because the same way I was able to multiply this together, I'm able to go ahead and do this as well. All right, I could break down square root of 150 to be 25 times 6 times x to the 6th power. Well, this gets interesting because I can take the square root of 125, and according to this, the square root of 125, I'm sorry, is going to be 5. So that is what I take out, 5. And then the only one that I cannot take out is going to be the 6, which the 6 stays inside. That's the first part. The second part is understanding about the index. The index here is going to be 2. So you want to ask yourself, how many times does 2 go into 6? How many times does 2 go into 6? Very good. And that's why the exponent here is going to be 3, because you guys said it. Well, 2 goes into 6 3 times here. And if there's anything left over, it'll be written inside the radical. So my final answer is going to be this here. All right. So I'm going to write this down as 5x to the 3rd power square root of 6. Then that is it. All right. I know this is new for some of you guys, and that's the part that we're going to be practicing on again and again and again. But I want to make sure that you guys start off practicing, all right? So let's take a look at the next question. Notice that the index here changes now. The index here is actually going to be 3, all right? So the index here is actually 3. So instead of doing the square root, which let's say square root of 9 is actually 3. Why? Because we actually had to find two numbers that multiply together that gives me 9. In this case, we actually had to find three numbers that multiply together that gives me 216. I'm going to show you one way of doing it, and I'm going to show you the other way of doing it. Well, one way of doing it is pretty much a simple method. If we calculate this, 3 times 3 times 3, well, 3 times 3 is 9. And what's 9 times 3? 27. This is not 27, so my answer cannot be 3. Okay? Well, let's try 4. 4 times 4 times 4. Well, if we take 4 times 4 times 4, that will give me 64. This is not 64, so my answer cannot be 4. And I'm not going to try 5. Why? Because if I multiply 5 times 5 times 5, it has to end with 5 or 0. So I could skip the 5. I could jump to 6. 6. All right. Now I'll write this down. 6 times 6 times 6. Well, if we multiply 6, all right, 6 times 6 times 6, it's going to give me 216. And that is what we have here. Okay, so my answer to this is going to be the number 6. That is going to be your final answer for this one here. All right, so whenever you have the cube root, you're finding three numbers that are multiplied together that gives you that particular number. Now, how do you do this on the calculator? Well, if we take the TI-30XA, all right, I'm referring to TI-30XA. If we take the TI-30XA, what I want you guys to do, step 1, okay, step 1, you're going to type in 216. Step 2, you're going to push the button that says second. Step 3, you're going to go ahead and push the button that says y to the x. If you notice in the green, I'm talking about the green, okay, if we look at the green, all right, in y to the x, you have this right here. You actually have x square root of y. Well, what this is telling you is telling that the calculator that we're going to change the index on this one here. Why? Because we're going to put a value for x. So step 4, you're going to go ahead and write what the index is going to be. In this case, the index is going to be 3. And of course, step 5 should just be equal to. Okay? So if we do that, 216 second yx 3, then equal to, your final answer should be 6 over here. Okay? Okay, for this one here, just go ahead and put it in your calculator, 4.84. Take the square root of that. It's 2.2. All right. Now, if you want to do it manually, of course, you could do, remember, we only went to 15 times 15, which is 225. You continue doing 16 times 16, 17 times 17, 18 times 18, 19 times 19. And of course, you're eventually going to come up with 22 times 22. 22 times 22. Well, 22 times 22, if you multiply it together, okay, it's going to give you 484. But since it's two decimal places, it's going to be 2.2 times 2.2, and that's how you get the same answer as well. All right. So let's take a look at this one then. This is similar to what we did before. Notice that we have the square root of 80. Well, the square root of 80, it is not a perfect square, okay? So we got to think about two numbers that multiply together that gives you 80. What are two numbers that multiply together gives you 80? Eight and 10, right? Well, let's think about this. Is 8? No, not yet. Is 8 a perfect square? The answer is no. Is 10 a perfect square? The answer is no. So we can do another number, which could be 16 times 5. Is 16 a perfect square? Yes. Is 5 a perfect square? No. But we could use these two numbers. I could rewrite this as 16 times 5 times b to the second power. Well, now that I know I could rewrite that, I could take the square root of 16. The square root of 16 is going to be, good, 4. And can I take the square root of 5? Nope. The 5 stays inside the radical. And then remember, my index here is actually 2. How many times does 2 go into that 2? Just once. So this will be b to the 1, which you don't really have to write that 1. So my final answer here is going to be 4b square root 5. All right, so let's take a look at the next one. Now, this is a new rule that deals with exponents. All right, in this one right here, we're actually dealing with a power to a higher power, okay? And this is called the power rule. All right, well, the power rule states this. If you have a, which is the base, let's say to the second power, and then you have it to a higher power, let's say this is 3. Well, what you're going to be doing, you're going to actually multiply 2 and 3. So you have a 2 times 3, which this will give you a to the 6. Well, if we look closely at what we have here, this is a negative 7 times b negative 2, and then this is to higher power of negative 9. Well, we're actually, like I said, it is a power to a higher power, so we're actually multiplying these two numbers here. This will give me a, well, what's negative 7 times negative 9? Good job, 63. Times, what's negative 2 times a negative 9? 18. So this is what we have. Notice that both of the exponents here are actually positive. We do not have to bring them up or down, because if they are negative, we can't bring it down or we can't bring it up. But in this case, both of them are actually positive, so we just leave it alone, and that's going to be my answer right there, guys. All right. Well, here goes another good one. So we have the square root of 18. So I need your help here, guys. Is 18 a perfect square root? Yes or no? Very good. Can I break 18 down? Give me two numbers that I could break the square root of 18. Very good. Somebody said 9 and 2. You're absolutely right. Because we can also do 6 and 3, but I cannot take the square root of 6 and I cannot take the square root of 3. So somebody said 18. You could rewrite 18 as 9 times 2. Well, what is the square root of 9? Good job. So this is going to be 3 times, and then the only one that stays inside is actually the 2. So your final answer here is going to be 3 times the square root of 2. This is important for you guys to understand that the number in the outside here, okay, and that's outside of the radical is actually being multiplied. So this is 3 times the square root of 2, all right? Now, this is another interesting one. So please pay attention to this one, okay? Whenever you see this here, okay, notice that the fraction is all in one single radical. Well, you could go ahead and rewrite this, even though it's like this, okay? Square root of 64 over 121. We could rewrite this as square root of 64 over the square root of 121. So notice, guys, you could go this way, but you can also go this way as well. And the reason we want to go in this direction here is because we could take the square root of 64. What is the square root of 64, guys? Very good, 8. And what is the square root of 121? Very good. So my final answer, guys, is this, 8 over 11. So I'll go ahead and put that in there, 8 over 11, and check. There you go. Now we're on the last one right now, all right? So let's go ahead and finish it off. Well, again, we have 75, okay? Can we take the square root of 75? Is 75 a perfect square root, yes or no? Anyone? Is 75 a perfect square root, yes or no? No? Very good. So can we get two numbers that multiply together give me 75, but one of them is a perfect square root? Which two numbers do you think they should be? Anyone? Which two numbers do you think I should get over here? That two numbers that multiply together gives me 75. Very good. So somebody chose 25 times 3, which we think about quarters, right? Because we deal with money all the time. 25 cents times 3 will give me 75 cents, which it is 25 times 3, times y times z squared. Well, we could rewrite this again, all right? We can take the square root of 25. Square root of 25 is just going to be 5. And we cannot take the square root of 3, so we leave the 3 in the inside. Can we take the square root of y? No, we cannot. Y goes inside because this is a 2. Okay, how many times does 2 go into that 1? It's none, so we leave it alone. And how many times does 2 go into that 2? It's just 1. So this is Z1. So my final answer is actually that right there. It's going to be 5Z square root 3y. 5z times the square root of 3y. All right. So that concludes this part of the section of exponents and radicals. All right.